In the silence of interstellar night, a fragment drifts, nameless, ancient, cold. It has crossed gulfs so vast that even the light of suns has thinned to whispers. This fragment, called 3I-ATLAS, is no ordinary comet. It is a messenger from beyond, the third confirmed object ever seen to enter our solar system from the infinite dark between the stars. Its path is not a circle around the sun, nor a curve drawn by gravity's patient hand. It is a straight, unbound trajectory, a scar through the sky, proof that it was born in another system, another world, another history. It may be the rubble of a shattered planet. It may be a shard flung from a young chaotic star, or the silent exile of a world long dead as it sails through our solar system. Telescopes capture its faint glow, a pale smear against the black. It does not notice us. It does not care. It is as indifferent as the void that delivered it here. Yet humanity watches with awe and unease. For if such a wanderer can pass unannounced, it can also collide. What would it mean if an interstellar object, heavier than mountains, older than our world, were to strike Earth? What would it mean if the end of one world, long ago, became the destruction of ours? The question lingers, like an echo in the dark. What if Atlas III did not merely pass by, but chose to fall? In the spring of 2019, the Hawaiian night was clear. On the summit of Mauna Loa, a pair of wide-field telescopes scanned the skies with quiet patience. This was the Atlas project, the Asteroid Terrestrial Impact Last Alert System, a robotic sentinel designed not for wonder, but for warning. Its mission, to detect small, fast-moving objects that might one day strike the Earth, night after night. It stitched together mosaics of the heavens, comparing one frame to the next, searching for anything that drifted against the stillness of the stars. Most detections were familiar: the endless ballet of near-Earth asteroids, faint comets, the routine clutter of our celestial neighborhood. But on one April night, something appeared that did not fit. It was faint, just another smudge of light. But its motion told another story. This object was not bound to the sun. Its orbit was open, hyperbolic, moving too quickly to be captured. It was falling in from the depths of interstellar space, and soon it would slip back into the dark. At first, it was designated C. 2019 U6, a cometary body. But as astronomers traced its trajectory, its true identity unfolded. It was named 3I-ATLAS, the third confirmed interstellar object ever seen. The 3I marked its place in history, following the strange, elongated visitor called Oumuamua in 2017. And the unmistakably cometary Borisov in 2019. 3 objects, 3 fragments of alien origin, 3 proofs that the stars beyond our sun do not keep their worlds contained. Scientists felt a surge of exhilaration and unease. For centuries, interstellar wanderers had been the subject of speculation and myth. Now, in the span of only 3 years, humanity had seen 3 pass through its backyard. The cosmos was not a sealed vault. It was porous, leaky, alive with motion. Telescopes across the globe turned their eyes to the faint traveler. They measured its brightness, its changing tail, its distance shrinking as it approached. Computers ran orbital models, charting the ghostly curve it traced across the solar system. Each calculation told the same story. This visitor had come from the void between stars, a fragment of another system, older than our species, perhaps older than the Earth itself. Cinematic metaphors filled the scientific imagination: a shard from a shattered planet, a splinter of ice torn from a distant Oort cloud, flung free by a giant's gravity, a fossil of creation carrying the memory of another sun's birth. And yet, despite the excitement, a darker thought lingered. The object had been faint, discovered late, only months before its closest approach. Had its path been slightly different, aimed not for a harmless pass, but for a collision, humanity would have had little warning. The catastrophe would have arrived as silently as the discovery itself. Astronomers described it with caution. Yet poets of science could not resist the image: a shadow slipping silently through the neighborhood of our sun. 3I Atlas was not the largest body ever to pass near Earth. It was not even the most mysterious. But it was a reminder that we are not alone in the dark sea of the cosmos, not in the sense of life, but in the sense of debris, fragments, refugees of creation. And every so often, these strangers cross our path. The discovery of 3I Atlas was more than a data point. It was a revelation, a whisper of connection between solar systems, and a warning that the sky is not ours alone. It was the first glimpse of a question that would echo far beyond 2019. What happens when the messengers of other stars no longer pass us by, but come directly toward us? The discovery of 3I Atlas was more than an astronomical curiosity. It was a jolt to the foundations of certainty, a reminder that the cosmos is not a closed system, but an open sea, its tides spilling debris across gulfs of unimaginable distance. For centuries, the comets and asteroids of our solar system were thought to be self-contained wanderers. Each of them, whether plunging sunward or drifting far into the frozen Oort cloud, belonged to our star. Their motions obeyed the strict geometry of orbits, ellipses, parabolas, closed loops, etched into the invisible fabric of gravity. They were predictable, charted, their returns marked on calendars, as if they were loyal pilgrims to the sun. But 3I Atlas was different. Its trajectory was not curved in devotion to our star. It was open, hyperbolic, unbound, a scar drawn across the solar system, never to return. The calculations spoke in stark numbers. Its velocity was too great, tens of kilometers per second, beyond the escape speed of the sun. No comet born here could move so quickly, nor follow such a path. Its very presence was proof of an origin elsewhere, another star system, another gravitational history, another sky. To the scientific mind, it was exhilarating. But beneath that exhilaration, there was unease. No early warning, no cycles to predict their return. Only sudden discovery, faint light in the night sky, already upon us. Unlike asteroids bound to our sun, which astronomers track with patient certainty, interstellar visitors defy foresight. They appear as intruders, their paths unknowable until they are already too close to ignore. They are like stones flung by invisible hands from the dark. Oumuamua had been the first, sliding silently through the inner solar system in 2017, its elongated body reflecting light like a shard of glass. 2 years later came Borisov, a comet, trailing the unmistakable gas and dust of frozen volatiles, as if announcing its alien nature with a luminous banner. Now, with 3I Atlas, the pattern grew undeniable. These were not accidents of observation. They were emissaries of a deeper truth, that interstellar space is not empty, but littered with fragments. The shock was not merely scientific, it was existential. If such fragments can enter unnoticed, what prevents one from intersecting our fragile orbit? The question hung heavy, sharpened by the knowledge of Earth's history. 66 million years ago, a single impact in the Yucatan ended the reign of the dinosaurs, reshaping life's story in an instant. That body was homegrown, born of our own solar system. But what of a body cast out from another star, carrying unknown mass, unknown chemistry, unknown strength? The unsettling truth was clear. Interstellar objects cannot be predicted. They do not belong to the great clockwork of our system. They arrive without invitation, indifferent to human timelines. By the time they are seen, they are already moving. On cinematic images haunted the imagination of scientists. A shard torn from a dying planet, a frozen messenger carrying the minerals of alien worlds, or perhaps a remnant from the dawn of creation itself, older than our sun, older than Earth, drifting across billions of years to appear suddenly at our doorstep. The paradigm was broken. The solar system was no longer a sanctuary enclosed by gravity's embrace. It was a crossroads, a corridor open to the endless highways of the galaxy. And with this realization came a deeper fear. For though 3I Atlas passed harmlessly, its trajectory a ghost through the neighborhood of the sun, there was no law that required the next one to do the same. Someday, one such object may not glide by, but collide. Someday, the stone cast from another star may strike the fragile shell of our world. That possibility hung in the silence of the night sky, invisible, unpredictable, waiting. And humanity, looking upward, could not help but wonder, what would happen if the path of a cosmic exile crossed the path of our fragile Earth? The discovery of 3-eye Atlas-set telescopes turning from mountaintop observatories to orbiting instruments above the atmosphere, all eyes fixed on the faint intruder. Each observation was an attempt to strip away the mystery, to translate dim light into knowledge. Astronomers began with brightness. They charted its light curve, measuring how it flickered against the dark, how the sun's rays struck and scattered across dust and ice. The numbers told a familiar story. This was no barren rock like some asteroids. It was alive with sublimation. As it drew closer to the sun, frozen volatiles, water, carbon monoxide, carbon dioxide boiled into space, unfurling into a ghostly tale. This set it apart from the first interstellar visitor, Oumuamua. That object, discovered in 2017, was silent and enigmatic, with no visible tail. Its shape defied expectation, elongated, perhaps like a spindle, perhaps like a flattened shard. Worse still, it accelerated in ways gravity alone could not explain, as if pushed by forces hidden in its structure. Oumuamua left behind more questions than answers, and to this day, scientists argue over whether it was comet, asteroid, or something else entirely. 2 years later came to Borisov. Unlike Oumuamua, Borisov was unmistakably a comet. It shone with the gas and dust of frozen materials sublimating in the sun's warmth. Its spectrum matched the chemistry of our own comets, as though comets everywhere are born from similar recipes in the disks that cradled newborn stars. Now, 3-eye Atlas followed. It, too, bore the hallmarks of a cometary body. Its nucleus was fragile, its surface venting into space. But this visitor seemed to disintegrate more violently than expected. Even before its closest pass, it fractured, evaporating piece by piece, as though the journey itself was too much to endure. To understand it, astronomers reached for every tool at their disposal. Spectrographs split its faint light into bands of color, searching for chemical fingerprints. In those patterns lay the clues of composition, the echoes of water vapor, carbon-bearing molecules, perhaps even exotic ices forged in the cold of another star's nursery. Orbital mechanics revealed the scale of its journey. Numerical simulations traced its path backward, far beyond the edges of our solar system, back into the void. Its velocity suggested it had wandered interstellar space for millions, perhaps billions of years before encountering the sun. It might have been ejected during the violent formation of another planetary system, cast adrift when giant planets migrated, scattering debris into the dark. Or it may have been a relic from a stellar death, torn loose as a star shed its material to the winds of space. Yet, even as the data piled higher, mysteries endured. The exact size of its nucleus remained uncertain. Estimates suggested a few kilometers across, large enough to be catastrophic if ever directed at Earth, but its fragility blurred the numbers. Was it a single, solid fragment, or a loose rubble pile, held together only by the weakest threads of gravity? Its disintegration offered hints. As 3-eye Atlas approached the sun, it broke apart into smaller pieces, each trailing dust and vapor. Some astronomers suggested that its structure was never strong, that it was a relic held together by ice that vaporized too quickly. Others wondered if it had endured close passes near other stars, weakened long before it reached us. The comparison with Oumuamua deepened the mystery. If interstellar objects can appear as silent shards or as active comets, what diversity truly drifts between the stars? Are we seeing a representative sample, or just the rare survivors that chance delivers into our skies? Numerical models suggested the galaxy could be filled with trillions of such bodies. Each star system ejects fragments during its youth. Planetary embryos collide, icy comets are hurled outward, and gravity scatters debris into the interstellar medium. Most drift unseen, never crossing our gaze, but occasionally, one slips into the inner solar system, carrying with it the fingerprints of a place humanity will never visit. For scientists, 3-1 ATLAS was a treasure, fleeting, fragile, but precious. Its chemistry hinted at universal processes. Its motion confirmed the openness of our cosmic neighborhood, and its demise, crumbling as it neared the sun, reminded us of the fragility of worlds adrift. Yet, for all the instruments trained upon it, much remained unresolved. Its exact place of origin is unknown. Its structure, never directly imaged, is left to inference and simulation. Its strength, its density, its full story, all vanished when it disintegrated, lost forever to the black. What lingers is not clarity, but a W. Despite our telescopes, our spectrographs, our equations, there is a limit to what can be known when a wanderer arrives only briefly before returning to the dark. Each observation illuminates a fraction, leaving the rest concealed in shadow. The probing of 3I Atlas revealed enough to confirm its alien birth, enough to distinguish it as comet-like, fragile, immense. But it also underscored a deeper truth, that the universe does not yield its secrets easily. These messengers from beyond arrive, reveal fragments of themselves, and vanish, reminders of how much lies hidden beyond the narrow reach of human eyes. And so the stranger slipped away, leaving behind questions without answers. It had been measured, dissected, analyzed, yet, like a ghost glimpsed at the edge of vision, its essence remained unknowable. The scientists who probed it were left with both knowledge and longing, knowledge of its interstellar origin, longing for what they could never hold. And in that longing, a realization took root. The universe is full of such wanderers, and each may bring with it both discovery and danger. It is one thing to witness a visitor glide silently through the solar system, its presence fleeting and harmless. It is another to imagine its trajectory shifted by the smallest fraction until it intersected with Earth itself. The thought alone is staggering, for 3I Atlas was no pebble of space dust. Estimates of its nucleus place it between 3 and 5 kilometers wide, a mountain of ice and rock, large enough to end civilizations. The numbers are merciless. At such a scale, the kinetic energy of impact would rival the detonation of hundreds of millions of nuclear weapons. The shockwave would not simply scar a region, but shake the planet. If it struck land, the atmosphere would ignite with incandescent fire. Forests and cities alike would vanish in a single blinding instant. If it plunged into the oceans, towers of water would rise higher than skyscrapers, racing outward as tsunamis that would drown coastlines across continents. The entry alone would be cataclysmic. As the body tore through the atmosphere, friction would compress the air into plasma, heating it to thousands of degrees. The sky would ignite. A roar louder than any storm would shatter windows a hemisphere away. And then the ground would quake as the cosmic mountain struck, releasing more energy than the Chicxulub impact that ended the reign of the dinosaurs 66 million years ago. But this was no ordinary comet. Its origin lay beyond the sun's reach, in the depths of interstellar space. Its chemistry was not known. What if its heart carried metals denser than any asteroid we have studied? What if it bore exotic compounds, forged in the violent nursery of another star? The consequences could not be fully predicted. Some models suggest the release of strange isotopes, unfamiliar dusts that might alter atmospheric chemistry in ways Earth has never known. What is certain is the aftermath. The skies would darken, filled with soot and vapor. Sunlight would fade. Temperatures would plummet in what scientists call an impact winter. Crops would wither in frozen fields. Oceans would chill. The fragile balance of climate that sustains life would collapse. The chain reaction of devastation would move slowly, inexorably, like a suffocating tide. Fires would rage in the days after impact, their smoke blotting out the heavens. Ash would fall like black snow. Within weeks, photosynthesis would falter. Forests would turn to silence, oceans to emptiness. Species upon species would vanish, unable to adapt to the sudden darkness. Civilization itself would not escape. Supply chains, electricity, agriculture, all depend on stability. With skies dimmed and harvests gone, famine would spread. Governments would falter. Nations would strain. And in the quiet that followed, humanity would face a truth as ancient as the cosmos. We are fragile in the face of celestial chance. The Chicxulub impact left a crater 180 kilometers wide. It extinguished 70% of life on Earth. A 3I Atlas impact could carve scars just as deep. It would not merely end an age of dinosaurs, but unravel the delicate web of human civilization. And yet, there is a deeper fear that lingers in the interstellar nature of such an object. Because its origins are unknown, its density, its strength, even its internal structure, are mysteries. A comet of our solar system can be studied, predicted, modeled, but a body from beyond, it is a riddle. It may shatter high in the atmosphere, exploding in a shockwave like the Tunguska event of 1908, but magnitudes greater. Or it may strike intact, delivering its full force into the crust of the Earth. Science cannot say with certainty, for we have never faced such a thing. In the mind's eye, the aftermath plays out in slow motion. The sky glows red as dust rises. Seasons vanish beneath perpetual twilight. The oceans boil where tsunamis met continents, then freeze in the sudden chill. The sound of impact echoes in the silence that follows, a silence broken only by wind carrying ash. Human eyes, if any remain, would look upward, not in wonder, but in grief, knowing the destroyer came not from Earth, not from our sun, but from the stars beyond. The irony is cruel. An object like 3IATLAS is a messenger, a piece of another world, a fragment of another time. It carries with it the story of creation in a distant system, the chemistry of alien skies. It is a relic of cosmic history, drifting for eons across the void. To scientists, it is treasure. To philosophers, it is proof of connection between stars. But if its path were to cross ours, that messenger would become executioner. The knowledge it carried would arrive in fire, in darkness, in extinction. And so the mind lingers on the possibility. What if one day an interstellar wanderer does not glide past, but strikes? What if the gift of knowledge it brings is written not in light, but in the erasure of life itself? The thought echoes through observatories, through laboratories, through the quiet spaces of reflection. For though 3I Atlas passed us by, the galaxy is full of such bodies. It is only a matter of time before another arrives, and when it does, humanity will look upward and wonder, is this the next messenger, or is this the end? Every interstellar visitor is a fragment of a story written far away in the silence of other suns. To glimpse one is to see not only an object, but a history, the violence and chaos of star systems in their youth, the collisions of planets unborn, the restless scattering of debris across the galaxy. Where, then, did 3I Atlas come from? What birthplace forged it, and what catastrophe cast it into exile? The most likely answer lies in the turbulent process of planetary formation. When stars are young, they are surrounded by disks of gas, dust, and ice. Within these disks, fragments collide, accrete, and shatter in endless cycles, slowly sculpting worlds. But not all fragments are bound to remain. The gravity of giant planets acts as a slingshot, hurling debris outward. Some pieces are flung into distant Oort-like clouds. Others are cast entirely free, sent drifting into interstellar night. It is a process repeated in countless systems. A cosmic wind scattering fragments across the Milky Way. Collisions also play their part. In the crowded nurseries where stars are born, interactions are fierce. Planetary embryos crash together, creating shards of rock and ice. A single violent encounter can eject debris at escape velocity, freeing it forever from its parent star. These fragments wander, crossing gulfs for billions of years, until chance aligns their path with another system, ours, or one beyond. There are more dramatic possibilities. Some interstellar wanderers may be shards of shattered planets, worlds that once carried surfaces, atmospheres, perhaps even oceans. A planetary system destabilized by migrating giants, or ripped apart by close encounters with other stars, might cast entire mountains into space. What arrives at our doorstep could be the fossil of an alien continent, broken and frozen, carrying whispers of landscapes no longer in existence. Others may be comets, flung from the icy reservoirs of alien systems. Like our own Oort cloud, every star may be surrounded by vast spheres of icy debris, disturbed by passing stars or galactic tides. These comets are set free. They drift between suns, carrying within them the frozen chemistry of their birth. Spectrographs reveal familiar signatures, water, carbon monoxide, cyanide, but they may also carry unique isotopes, materials forged in stellar furnaces unfamiliar to us. Scientific models suggest the galaxy is littered with such bodies. For every star, billions of fragments may wander the void, They do not announce themselves. Most are too faint to see. Only a rare few cross paths with our telescopes, becoming fleeting points of light against infinity. What we detect is but the tiniest fraction of an ocean of fragments, an unseen rain that has fallen since the dawn of stars. Yet, among the plausible, there lingers the speculative. Not all agree that interstellar visitors are mere rubble. The strange acceleration of Oumuamua, unexplained by gravity alone, has inspired bold hypotheses. Astrophysicist Avi Loeb suggested it might not be natural at all, but a fragment of alien technology, perhaps a light sail cast adrift. Mainstream science remains cautious, favoring explanations rooted in natural physics, outgassing of exotic gases, non-gravitational forces hidden in its structure, subtle errors in observation. These may yet account for the anomaly. But the very fact that such questions can be asked reveals how unsettling these wanderers are. They are unlike anything humanity has known, and so speculation blooms in the spaces data cannot fill. More grounded is the possibility that such objects are couriers of life itself. The theory of panspermia suggests that comets and asteroids can carry organic molecules and perhaps even microbial seeds between worlds. In the violent youth of planetary systems, impacts could launch debris into space. Shielded within rock or ice, life's precursors might endure the journey across interstellar gulfs. If even a fraction survived, then interstellar wanderers are not only threats, but messengers of possibility. They may have seeded Earth in its infancy, delivering the raw ingredients for biology. Or they may carry the chemistry of life to worlds we have never seen, spreading the spark of complexity across the galaxy. This is not fantasy, but speculation rooted in observation. Meteorites on Earth already contain amino acids, the building blocks of proteins. Comets in our system are rich with carbon-based compounds. When interstellar visitors like Borisov are studied, their chemistry mirrors this richness. The implication is profound. The ingredients of life may not be unique to our solar system. They may be universal, scattered by wanderers like Atlas across the galaxy, and so interstellar objects become more than curiosities. They are time capsules of other systems, fragments of other histories, potential carriers of the same chemistry that gave rise to us. Each one is both a threat and a promise. A threat because their trajectories are unpredictable, their impacts catastrophic. A promise because their existence ties us to the greater story of the galaxy. They whisper of unity, that matter itself circulates between stars, binding distant systems into one vast ecosystem of exchange. To watch one pass is to glimpse the flow of the universe's hidden commerce. Stars scattering their fragments into night, fragments wandering across gulfs, gulfs bridged by chance encounters. We are not isolated islands of matter, but nodes in a galactic web of debris. Every interstellar visitor is proof of this invisible connection. The theories, then, converge on a paradox. Interstellar wanderers are ordinary, born of collisions, gravity, and ice, the natural outcomes of star systems. But they are also extraordinary carriers of alien chemistry, perhaps even of alien history. They may be as common as sand, and yet each one is precious, unique, irreplaceable. And above all, they remind us of fragility. For the same fragments that may scatter life can also end it. The same bodies that may carry organic seeds may also carry extinction. It is a duality written into the fabric of the cosmos, creation and destruction, promise and peril, entwined in every stone cast across the stars. 3I Atlas was one such stone. Its theories of origin range from the mundane to the sublime. But what matters is not which is true. What matters is the reminder it carries that the galaxy is alive with motion, that the fragments of distant worlds do not remain distant, and that sometimes they arrive unannounced, bearing both mystery and warning. In the silence of night, the Earth keeps watch, arrayed across mountaintops and deserts, circling high above the atmosphere, orbiting far from the home world itself. A fragile network of eyes scans the abyss. These are the guardians of the planet, not soldiers nor fortresses, but instruments of glass and silicon. Their task simple and impossible: to see the stone before it strikes, The first line of defense is vigilance. In Hawaii, the asteroid terrestrial impact. Last alert system, Atlas, sweeps the sky in rhythmic arcs. Its twin telescopes are designed to capture the faint signatures of moving bodies, scanning the heavens several times each night. It was here that the faint smear of 3IATLAS was first caught, a ghostly point sliding against the stars. Nearby, PanSTARRS, the Panoramic Survey Telescope and Rapid Response System, adds its vision to the watch. Its wide-field camera peers deep, collecting terabytes of data, charting the dance of asteroids, comets, and the occasional visitor from beyond. Together, these instruments are humanity's early warning system, our lanterns in the storm. Soon, an even greater eye will open. On the high plateau of Chile, the Verisi-Rubin Observatory prepares to scan the entire southern sky with unprecedented depth and speed. Its legacy survey of space and time, the LSST, will map billions of stars, galaxies, and moving objects. It promises to reveal faint wanderers long before they cross too close. For interstellar bodies like 3IATLAS, this may be our only chance to intercept them while they are still inbound, not vanishing into the black. But detection is only half the battle. If an object were truly on course for Earth, what then? In 2016, NASA established the Planetary Defense Coordination Office, a small but vital effort to coordinate the detection, tracking, and potential deflection of hazardous objects. Its mandate is both practical and philosophical, to ensure that humanity is not blindsided by the same cosmic forces that ended the age of dinosaurs. Missions have already tested what is possible. OSIRIS-REx, launched in 2016, rendezvoused with the asteroid Bennu, sampling its surface and returning fragments of primordial matter. Its precision proved that humanity can not only track but touch these ancient bodies. Then came DART, the Double Asteroid Redirection Test, in 2022. For the first time in history, a spacecraft deliberately altered the path of a celestial body by crashing into Dimorphos, a moonlet orbiting the asteroid Didymos. DART shortened its orbital period, demonstrating that even small interventions can change destiny. It was not merely a scientific triumph, but a philosophical one, proof that the species once vulnerable to the sky can, in time, shape its own fate. And yet, against interstellar wanderers, the challenge deepens. Unlike near-Earth asteroids, their velocities are greater, their arrival sudden. There is little time to prepare, little warning before they streak through the inner system. Intercepting them would require new strategies, fast chasers, rapid response missions, perhaps even probes, launched in advance, waiting in the void to rendezvous with the next alien fragment. Concepts have already been proposed. Interstellar interceptors, spacecraft designed to lie in wait, powered by solar sails or nuclear propulsion, ready to leap when the next object is detected. They would not only defend, but study, offering humanity its first close glimpse of matter born beyond the sun. The dream is audacious, but the clock is always running. For every visitor, like Oumuamua, Borisov, or Atlas, there are likely millions we never see. They pass unnoticed, too faint, too fast, hidden by the vastness of space. Even the most advanced surveys are lanterns in an endless storm, precious but fragile. The metaphor lingers. Imagine standing in a gale, holding only a single lantern. Stones are flung unseen from the darkness, some missing, some grazing close. Any one of them capable of shattering everything. This is humanity's position in the cosmos. Our lanterns are telescopes, our sentinels are observatories, and still the night is vast. Each detection is a victory, but also a reminder. We are small, our reach limited, our instruments delicate against the scale of the void. And yet, this fragile watch is all that stands between awareness and ignorance, between preparation and catastrophe. There is humility in this work, but also defiance. For to lift instruments toward the stars is to refuse to be blind, to map the orbits of unseen bodies is to assert that fragility need not mean helplessness, and to test deflection, interception, and study is to take the first steps toward a species that is not merely subject to chance, but capable of response. Still, the greatest challenge remains the unknown, an interstellar body like 3i Atlas, is not only a threat, but a fleeting opportunity. It carries within it the history of another system, a fragment of another star's story. To intercept one would be to hold, for the first time, material born beyond our sun. It would be both defense and discovery, survival and science, entwined in the same mission. And so, as the watch continues, humanity stands at a threshold. We peer into the abyss with fragile eyes, racing against time, hoping to see before it is too late. The storm is vast, the lanterns small, but still they burn, and in their glow lies a fragile promise that we will not face the next wanderer. In blindness, in the stillness of the cosmos, even destruction is part of a greater rhythm. Stars ignite, shine, and die. Planets form, collide, and dissolve. From every end, fragments scatter into the dark. And so, drifting between the suns of the Milky Way, there are objects like 3IATLAS, cosmic refugees, born of impermanence, carrying within them both memory and threat. To witness such a body is to be reminded that nothing lasts forever. Not the stars above, not the systems they cradle, not even the planets beneath our feet. Every celestial body is transient, each bound to decay. Even the sun, radiant and seemingly eternal, is only a temporary fire. One day, its hydrogen will run dry, and it too will shed fragments into space. What humanity sees in 3i ATLAS is not an anomaly, but a reflection of what all matter must one day become, a wanderer torn from its home. Yet impermanence does not mean emptiness. In every fragment lies a duality. These messengers are both creators and destroyers. Their collisions can erase life in an instant, plunging Earth into darkness and extinction. But they may also deliver the chemistry of beginnings. Comets in our own system are rich with organics, with amino acids, the alphabet of life. If such compounds drift between stars, then interstellar wanderers may not only threaten life, but seed it. A strike can extinguish, but a smaller fragment might enrich, scattering the molecules of possibility upon barren worlds. This balance of creation and destruction is written into the very fabric of the universe. Every interstellar visitor is a reminder that the forces which nurture are also the forces which destroy. The same collisions that birth planetary systems also cast their debris into the abyss. The same impacts that end species also clear space for new ones to emerge. The cosmos is not cruel nor kind. It is simply vast and indifferent for humanity. The presence of these strangers strikes a deeper chord. Civilization rests on fragile foundations, stable climates, fertile soils, reliable harvests. Yet all of this could be undone by a single stone from beyond the sun. It is humbling to realize that the fate of cities, nations, and cultures depends not only on human decisions, but on the invisible trajectories of bodies we cannot yet see. We are a species at the mercy of cosmic chance, survivors not because of strength, but because the stones have not yet found us. But fragility is not the only truth. There is also connection. If fragments can cross the galaxy, then matter itself is not bound to one place. The dust of stars mingles with the dust of others. The chemistry of one world may seed another. The theory of panspermia suggests that life may be nomadic, traveling hidden within comets, protected by ice and rock, surviving journeys that span millions of years. If so, then life is not isolated, but shared. It does not belong to any one star system, but to the galaxy as a whole. And this raises a haunting question. If life can travel, then what are we? Could the spark that led to humanity have been carried here by a stranger long ago? A fragment like 3IATLAS, cast from a distant sun. If so, then we are not only children of Earth, but children of the galaxy, heirs of countless collisions and wanderings. We may be cosmic refugees without even knowing, born not of isolation, but of exchange. The thought transforms every interstellar visitor into something more than rock or ice. They become letters written by other stars, delivered across eons. Each carries within it the handwriting of another system, its chemistry, its history, its violence, its fragility. To study them is to read these letters aloud, piecing together the larger story of how matter moves, how life might spread, how impermanence itself binds the galaxy into a single restless whole. Yet with each visitor comes not only wonder, but fear. 4 letters are not always gentle. Some arrive as messengers of doom, reminding us that life's continuity is not guaranteed. The same letter that whispers of distant worlds may also carry the signature of extinction. And so, humanity stands in a paradox. Each cosmic stranger is a symbol of possibility and peril. They remind us that we are fragile, but also that we are part of something larger, that death and creation are threads of the same tapestry, that to exist at all is to share in the restless circulation of matter across the galaxy. In this way, interstellar wanderers reveal not only the fragility of humanity, but also its dignity. For unlike any other species, humans have looked upward and understood. We have read the trajectories, calculated the velocities, and realized that these are not local stones, but fragments from other suns. We have recognized ourselves in their impermanence, and wondered if we share in their exile. And perhaps that is the deepest meaning. To see 3i Atlas is to see ourselves, transient, wandering, fragile, yet luminous for a time. We are messengers too, carrying the chemistry of our world into the future, into space, into whatever comes after us. The galaxy is full of such wanderers. Most will never be seen, most will never be named, but every so often, one crosses our skies, and for a brief moment, humanity is reminded that we are not alone in matter, reminded that we are bound by impermanence, reminded that in the silence of the cosmos, even strangers have meaning. And so, the deeper meaning of 3i Atlas is not only what it is, but what it reflects. It is a shard of another world, but also a mirror of our own. A message written across time, that to live is to wander, that to exist is to be fragile, and that every fragment, no matter how small, carries within it both the possibility of endings and the promise of beginnings. In the beginning, there was only a shadow, a faint smear of light against the stars. 3i Atlas entered our skies as a stranger, a wanderer from another sun, indifferent to the world it passed. It reminded us of impermanence, of fragility, of the chance alignments that shape existence. If its path had been different, we would not be here to wonder. If the stone had not slipped silently past, but instead fallen upon earth, history itself would have ended in fire and silence. Civilization, memory, even the act of reflection, all erased by a fragment cast adrift millions of years before our species began. But it did not stray. It passed by, quietly, vanishing again into the black. It came not as execution, but as reminder, a whisper that the cosmos is vast, that its stories are real, and that humanity lives only by the grace of their absence. We are a vulnerable species. Our bodies are small, our lifespans brief, our world fragile against the scales of cosmic violence. And yet, we are also awake. We build telescopes on mountaintops and in orbit. We trace the arcs of unseen bodies across the sky. We send spacecraft to touch ancient stones, to test deflection, to turn fate into choice. No other creature has lifted its gaze in this way. No other has recognized in the wanderers both danger and beauty. This duality defines us. We are fragile, yet capable of awareness. We are impermanent, yet able to imagine futures beyond ourselves. We are at the mercy of chance, yet daring to confront it with knowledge. Perhaps this is the greatest gift of interstellar visitors. Not their chemistry, not their mystery, but their reminder. They show us that in a universe of endless darkness, life has found a way to be conscious of itself. That on a small blue world, surrounded by fragility, there exists a species that can see, calculate, and wonder. And so, as 3i Atlas fades back into obscurity, it leaves behind more than data. It leaves a reflection of our place, vulnerable, in the storm, yet luminous for a time. Perhaps the greatest gift of Atlas 3i is not its threat, but its reminder that in a universe of infinite darkness, we are awake and we are watching.